My name is Adam. I'm Chris.
I'm Alex.
Daniel.
Moshe.
And we are Let My People Code. So, that's on the wrong page. We are working with Qualcomm to create robots that are powered by smartphones. Long story short.
The robot we are working with is called an MDR, which stands for Mini Dragon Rover. The MDR is built on a 3D printed chassis provided by Qualcomm, and it includes 2 wheels, one on each side with treads, and moves similar to a tank. Each wheel is independently controlled by a servo motor. There's also a mirror and a forklift on the rover. On top of the MDR sits an Android phone, and its camera faces the mirror, which allows it to view forward, and this rotating mirror can allow it to view different angles. The MDR is controlled by the Android phone. However, it cannot directly communicate with the servo motors. So inside of the MDR is a yo-yo board, which acts as a logical interface between the phone and all the servo motors inside.
Now you might be asking yourselves, what can we actually do with a robot powered by a smartphone? And the answer is a lot. It's very easy to underestimate just how powerful smartphones are these days. In my hands, I'm holding a computer with a quad-core multiprocessor, access to multiple wireless capabilities such as Bluetooth and Wi-Fi, as well as a camera that can take pictures, create a video stream, and in real time process that video stream using computer vision libraries such as Qualcomm's Vuforia. Putting these 3 together makes, along with other features such as accelerometers and compasses, make for actually a very powerful and versatile robot. And so by merging the ease of production of a 3D printed chassis with the mass production of a smartphone would allow robotics to be much more accessible to the average power user.
So now that he answered what we can do with it, you might be asking, what are we doing with it? We have 2 main goals. The first goal is to implement a web interface remote control, which will allow you to control your rover from any internet-enabled device that has a browser. The second main goal is to implement indoor positioning, which means that you can locate your rover within the vicinity of your home on a map similar to this. Now, once these 2 goals are achieved, we hope to implement autonomous movement, which means that by clicking or tapping on this map, you designate to the rover where it must navigate to without any further assistance. Once this is achieved, we hope to implement games, surveillance, and target tracking and pictures. Now, also note that since everything is open source, anything a developer can think of and is willing to implement themselves with these features is possible.
So we had a demo planned, and I was going to be able to show part of the demo, but it appears due to the internet settings at the school, we cannot seem to connect to this properly. Try it one more time, but it does not seem to be querying the server properly right now. So I will just demonstrate our portal, which would be normally working if the internet wasn't acting up right now. So as mentioned previously, this is an internet-enabled device, and therefore it uses the internet to communicate to a server to get information about what it should be doing. Here on the screen, I have the control panel to our main rover control navigation. We have 4 green dots here representing what would be Bluetooth beacons to navigate the actual rover inside a house, a room, whatever it is. And the red dot is supposed to represent our rover. Right now, it's on the map mode, but you are also able to switch it to a live video stream, which is why I was asking the earlier group about some of the web protocol stuff they're using for video streaming, because we're looking to do some of that in the near future. Right now, this would just demo some of the movements that you would actually see from the camera on the rover, if it were to actually be moving on its own right now. And then you would be able to remotely control the rover's actions based on the video camera. Going further down the page, you would be able to take screenshots, still shots, just if you don't have the capacity at the current moment to stream from, let's say, your mobile device, because this page is designed in HTML5, therefore it works with mobile, tablet, PC, laptop, anything. Be able to change the positioning of the camera so you can angle where you are looking with the rover if you don't want to necessarily just look forward. You have your arrow keys per se, move forward, left, right, back. last, you'd be able to change the motor speed, move the forklift up and down, and we have a couple other ideas that we're looking to implement in the future, such as being able to set a heading where you can say look north, south, east, west for a specific angle, be able to time how long it takes for a certain action to be completed. For instance, if you wanted to race your friends with these rovers around a track, something silly. And lastly, the image targeting, where it will identify a target using the camera and the computer vision libraries and follows a target around the room. For instance, say you stuck a sticker on the back of someone's head. It will identify the sticker and follow them as they were moving throughout the room.
So the map you saw, well, for our demo, it was just kind of a simulation of the positioning, but the real thing's not there. So you're probably wondering how we're actually going to accomplish that. And the answer is with Bluetooth beacons, like this. I have one with me right now. So the plan is you put a bunch of them around the room like so, and it uses their relative signal strength, sort of like indoor GPS satellites. You gotta fix them where it is. So we've experimented with one algorithm so far with limited results. It wasn't quite accurate enough. So we're probably gonna perfect this more next quarter and tweak things.
And that's it for our presentation. Are there any questions for our team?
Can you control it through the browser with like your keyboard, or do you have to click?
So that's very simple to add in terms of a web browser. You can either use the key or the buttons on the screen. For instance, if you're on a smartphone, you're more than likely going to be using that. And if you're on a web browser, we can attach a simple JavaScript listener to detect left, right, up, down, and map it to those buttons.
Yeah, because I was wondering if you map it to buttons, then you can use like Arduino to make a controller and use like a PlayStation controller or something.
Interesting idea.
The end idea, which would be really cool, since it knows where it is to have it like autonomously move. So you just point like, go here, and it just.
But instead of like racing your friends, you put two Xbox controllers and you race your phone around the room.
So the idea is it would be able to do, it would be hybrid where you could move it wherever you wanted to based on the map, or you could manually control it as we're supposedly doing now.
Yeah.
Right, from a different system. They don't necessarily have to be in front of it.
It's open source, I'll do that.
Any other questions?
How are the Bluetooth beacons kind of programmed? Is it specific to, I guess, that one rover? Could I somehow hack it and bring my own beacon and mess up the demo? Not that I would.
Yeah, well, each of them has their own unique ID, and it turns out these beacons are actually encrypted, which was kind of fun to figure out how to use it, but we got it working eventually. So these, you actually couldn't mess with it because they have a rolling encryption, so you can't like spoof IDs.
Well, what's the encryption method? I challenge that.
It's well, there's like a shared secret on Qualcomm servers, and it'll like change every now and then based on some like the shared secret, which is also in here, which we can't see. So you have to like periodically like resolve it to the server. It changes every like hour or so.
Okay, so it's a clock key, right?
The idea also is that these beacons would be pre-programmed per se with your designated rover, so that if you brought in a beacon and tried to cause some interference, it wouldn't even care about your beacon signal, since we would have our own identifiers assigned with our beacons already. Any other questions?
Is that a newer model of the rover right there?
Yes, as you saw last time when we presented, the treads that we have on the tank version seem to be sometimes unreliable and pop off. So we told Qualcomm about this issue. They sent us new front wheels and then like a little tricycle kind of ball on the bottom, like an old mouse pad that rolls.
What kind of localization algorithm did you try in the past? What didn't work about it?
So it's called trilateration, which is the exact same one GPS uses. So that part of the algorithm wasn't that hard to do. The hard part is converting. We're using a signal strength to determine range. The hard part is converting a signal strength into distance, because it's very noisy indoors. Like if we were in space and the radio signal went perfectly outward in a perfect sphere, it's a very easy model. But the thing is indoors, it's like bouncing off things and there's interference, that kind of thing.
I mean, GPS actually uses the time of flight of the signal to figure out its location, not the signal strength.
Well, yeah, no, But the way, but it gets the distance to satellite, and then after it gets the distance, it uses trilateration to get its own location. So that's what we use.
It's what you're using the signal strength.
Yeah, not time of flight. We'd have to have like atomic clocks to do that.
Also, in terms of the encryption, Qualcomm was not helpful at all with that, and Chris pretty much figured it out all himself.
Pretty much hacked the beacons.
So are you guys gonna spend, what's your plan for next quarter? Where's your time going? There's a lot of stuff on your list there. A lot of that stuff is not easy to do well. Even the localization problem by itself is.
So that is our main problem.
Okay, that's the heart of what you're trying to do.
That is the heart of what we're trying to do, is identify where the rover is in a certain room based on these beacons with whatever algorithm we end up settling on. And then from there, the autonomous movement won't be as difficult because we'll know where the position is always, and we should have, per se, if this were in our house, such as one of our other slides we're showing. This one where it shows like you have objects in the house, you have like a couch, you have a coffee table, bed, etc. It has to know not to run into these objects. So that would be really cool if we were able to get the localization so fine-grained and it knew where these other objects were, using maps pre-laid out and then also computer vision libraries to navigate itself.
Okay, so two questions follow then. What is the definition of success for you in terms of localization? What error is acceptable to you? And two, what is the methodology you plan to use in order to, it sounds like you need to do experiments, right? To figure out what's gonna work. So what's your planned methodology there to sort of try to figure out what the best thing is?
So I believe with our current algorithm, we have it configured so that 8 foot, 1 foot is our region of error at maximum, worst case scenario. But the idea with the trilateration algorithm is if you add more and more beacons, it will become more accurate, so that can help reduce the error. And then the second system that we're looking into doing is related to teaching the rover about its surroundings, and that would be less error, so that it would be able to kind of figure out what is around it by doing a bunch of simulations slowly over time, and it will learn where it's at. And it'll still use some of these beacons also to try to help it figure out exactly where it's around, but it will know its surroundings per se.
Yeah, like the new one, the old one's like ranging, so it's like conversely with the distance. We need the distance really important. The new one we want to do is you basically just like move it around a little bit. It takes measurements of signal strength and it learns where the beacons are. It like learns like, okay, this signal strength means I'm here, this means I'm here. And that means you don't have to put the beacon's position in beforehand, which is a huge pain to do. You could like I was like taping it to the roof of my apartment and like measuring them with string and yeah. So this new one seems a little better.
Okay, thank you very much.